Almost everyone enjoys hearing some kind of live music, but few of us realize the complex process that goes into designing the acoustics of concert and lecture halls. The environment of the coral reef is formed over thousands of years by the life cycle of vast numbers of coral animals. The main architect of the reef is the stony coral, a relative of the sea anemone that lives in tropical climates and secretes a skeleton of almost pure calcium carbonate. Its partner is the green alga, a tiny unicellular plant, which lives within the tissues of the coral. The two organisms coexist in a mutually beneficial relationship, with the algae consuming carbon dioxide given off by the corals, and the corals thriving in the abundant oxygen produced photosynthetically by the algae. When the coral dies, its skeleton is left, and the other organisms grow on top of it. Over the years, the sheer mass of coral skeletons, together with those of associated organisms, combined to form the petrified underwater forest that divers find so fascinating. The ozone layer of the atmosphere protects Earth from harmful solar radiation, but the ozone sphere is fragile, and evidence indicates that it is thinning. Since 1975, the amount of radiation reaching Earth has increased steadily. The implications of this are not good. Solar radiation causes cancer and contributes to other serious illnesses. Also, as radiation increases, more and more warm air gets trapped near Earth, and hot, humid conditions like those in a greenhouse begin to prevail. Some scientists warn that within 50 years, people could be facing major climatic changes and sea level far above what they are now. Public outcry about the issue has led to international efforts to stop the releases of CFCs and other pollutants harmful to the ozone sphere. Thanks to a global pact to eliminate the production of CFCs by 1996, the ozone layer should stop losing ozone around the turn of the century. Total ozone recovery, however, is predicted to take more than a century beyond that. For thousands of years, smallpox was one of the world's most dreaded diseases. an acutely infectious disease spread by a virus. Smallpox was the scourge of medieval Europe, where it was known by its symptoms of extreme fever and disfiguring rash as the invisible fire. In many outbreaks, mortality rates were higher than 25%. Ancient Chinese medical texts show that the disease was known as long ago as 1122 BCE, but as recently as 1967, more than 2 million people died from the disease annually. A method of conferring immunity from smallpox was discovered in 1796 by an English doctor named Edward Jenner. It was not until 1966, however, that the World Health Organization was able to marshal the resources to launch a worldwide campaign to wipe out the disease. In an immense project involving thousands of health workers, WHO teams moved from country to country, locating every case of active smallpox and vaccinating all potential contacts. In 1977, the last active case of smallpox was found and eliminated. Since there are no animal carriers of smallpox, the WHO was able to declare in 1980 that the dreaded killer had been conquered. For the first time in history of medicine, a disease had been completely destroyed. Usually regarded as pests, the termites of South Florida provide an excellent illustration of nature at work. In the natural world, when two or more different organisms coexist to each other's benefit, it is called a symbiotic relationship. The dominant member of the symbiotic pair or group is known as a host, while a smaller, less dominant member is a parasite. A classic symbiotic relationship of this kind takes place in the digestive tract of Florida wood-eating termites. We think of a termite as being able to digest wood, but it really cannot. The termite plays host to parasitic protozoans, single-celled organisms that lived in the termite gut. The protozoans provide the termite with the service necessary to its survival. They digest the cellulose in the wood that it consumes. Tunnel construction is costly and dangerous, but new technologies are allowing tunnelers to work more quickly and safely than ever before. Today's rock tunnels are being drilled by modern full-phase tunnel boring machines, TBMs. The drilling end of a TBM consists of a rotating cutter head whose diameter covers the entire face of a tunnel. As the cutter head turns, hard steel blades cut steadily through the rock. The first successful hard rock TBM was built in 1957, and many improvements have been made in TBM design in subsequent years. Developments in TBM technology have helped spur ambitious new projects. Most notable is a 50-kilometer Eurotunnel, also known as a channel, which has been bored by modern TBMs beneath the English Channel. The tunneling was done by British and French teams that started on opposite sides of the channel and eventually met underground in the middle. Thus, TBMs have contributed to building a technological and cultural milestone. Trains can now travel between England and France, in less than an hour, and for the first time in history, Britain and continental Europe are linked by land.